Okay, with 4-7, we're going to learn how to solve linear equations using graphs. We'll start out with solving them algebraically, and then check the solution on the graph, and then we'll flip that, and we will solve it graphically and check the solution algebraically. So, solving linear equations and checking solutions graphically by using a graph. We need to write the equation in the form ax plus b equals 0. We need to write it in the related function y equals ax plus b, and then that is the form we will use when we need to graph. So you'll notice that this is, whoa, sorry about that. Let's undo that. I didn't realize that wasn't locked there. You will notice that this is similar to y equals mx plus b that we've been using for graphing. So let's go ahead and do the first one again. The first one we're going to start out algebraically, and then we're going to move to the graph. And then in example 2, we will do just the opposite. So first of all, we need to solve this algebraically. How do we do that? So the first thing that we need to do is get our like terms together. So to get like terms together, I'm going to get rid of my constant term on the left side. So I'm left with 2x, and then when I add that, equals 6. Remember, balanced equations have to have the equal sign in between them. Now, to solve just for x, that's what algebraically means, I'm going to divide both sides because this was 2x's. I don't want to know 2x's. So now I've got to the solution of x equals 3. Okay? Now, that was algebraically. Now it says write the equation in ax plus b equals 0 form, because that's going to be how we're going to check it graphically. Okay? So let's change it to the ax plus b equals 0 form. So this time I have my 2x minus 5 equals 1. And I need it to equal 0. So this time I'm going to get rid of the 1, and I'll end up with 2x minus 6 equals 0. Now, if I write that related function in two variables instead of 0, I will get it in the form of y equals, I'm changing my 0 to y, 2x minus 6. And that is in my slope-intercept form. All right? So by doing that, I can see, and let's put that on the next screen. I think I've given myself a graph there. So let's copy, go to my computer a minute. Let's copy our two equations here. So this is the equation that I'm going to graph. So I'm going to copy that, go to my next page where we're going to graph it. I'll paste it there, scoot it up here a little bit. And then we're also going to go and copy what we found out when we were solving it algebraically. So I'm going to copy that one as well. And let's paste that onto this graphing page. And we'll see what those two things mean then. Okay, let's go ahead and graph it then. We're going to start at our b term. That's our beginning. Y equals mx plus b, and my b term is negative 6. B is my y-intercept, so I'm going to go down 1, 2, 3, 4, 5, 6. Let's get on our pen. 1, 2, 3, 4, 5, 6. And there's going to be my y-intercept. Okay? Now it's going to be a positive slope, remember that. And my slope is my m here, which is 2. I need it to be in rise over run, so we're going to change it to 2 over 1. So I'm going to go up 2, and I'm going to go to the right 1 because it's positive. Up 2 to the right 1. I can keep doing this to the right 1. All right, and then we'll go ahead and I'm going to try to freehand a line for us here today. So if I can make it through. Oh, I did pretty good. considering you get a little bit of a shadow. So you can see that that's going to be my graph for y equals 2x minus 6. Now, the other value that we found was when x equals 0. Remember when we have the equation x equals 0, that means y is going to be at 0. I'm sorry, when we have x equals a quantity, x equals 3, that means we don't have a y value, y is going to be 0. And look what we have here. We have x, y right here, and we have it as 3, 0. This point right here is 3, 0. So in fact, x equaling 3 is a solution to that linear equation because when we graph that equation, we found that it does go through the point x equals 3. Now, doing that in reverse, we're going to solve it graphically first, and then we're going to check it algebraically and see if that point is on the graph. So the first thing we need to do is look at that original equation, and we need to make sure that we're going to subtract the 2x. We want to get it in the ax plus b equals 0. So we have to get rid of that 2x. So we're going to subtract 2x from both sides. Now be careful. They gave you a kind of hard one right away to begin with that fraction there. So I'm going to say, I'm going to work this part out over here to the side. I'm going to change it to a white. So 4/3 x minus 2x. How do I add or subtract fractions? I have to have the same denominator. So let's keep our 4/3 x. And then if I want my 2x to have a 3 as the denominator, I need to multiply the top and the bottom by 3. 3 over 3 is 1, so I can do that. It's just going to change the name of my fraction, not the value. So it will change to 6x over 3. 2x is the same as 6x over 3, because if I would go ahead and reduce that, the 3 goes into 3 once and 3 goes into 6 twice, and I would end up with 2x. But I need that to be able to subtract. So 4/3 x minus 6/3 x would give me a negative 2/3 x. So now putting that back into my equation, let's go ahead and do that. I combine those terms. So now I have a negative 2/3 x, and I'm going to have that plus 3 equals 0, because we didn't finish up here. Okay, when I do that, I have that in the ax plus b equals 0 form. Now, when I want to graph it, however, I need it to get into the y equals mx plus b form. So I need to, for that part of it, I need to go ahead and set that to equaling 0. So let's go ahead and what do I want to copy for you here so that we can, okay, so we have the related function of y equals, I can write it right here, y equals negative 2/3 x plus 3. Okay, once I had it set to 0, I can change it to y. Okay, so there is going to be my slope-intercept form. Because this time we're going to graph it first. Oops, I wrote in my b instead of writing in my 3. All right, let me go ahead and copy that to put on the next screen where we're going to graph it. So, copy my slope-intercept form. Paste that on where I'm going to graph it. All right, let's go ahead and graph it, and then we will solve it algebraically and see if it really does pass through that x value. So first of all, just graphing it. This is solving it by graphing it and checking it algebraically. So going back to graphing it, start at the beginning. That's going to be my 3. So 3 is my y-intercept. That's b. Let me go ahead and write that in there for you. Y equals mx. Oops, I lost my x. Plus b. So my beginning is 3, 1, 2, 3. Now you'll notice I have a negative slope, negative 2/3. So I'm going to come down 2 and over 3. 1, 2, 3. Remember, either the denominator or the numerator is negative. That time I let the numerator be negative. Let's go back to our original beginning point. And this time I'm going to go up 2, but then I'm going to let my denominator be negative. 1, 2, 3. So solving it graphically, this is what I get. Now remember, I'm not perfect there, so I bet you I was supposed to hit the x-intercept just slightly different there. Oh, not just slightly. I'm way off on that one. I'm going to undo my line there. Alrighty. Let's see. So we have our point at our y-intercept at 3, and then I came over 2. Came down 2 and over 3. That's good. Up 2 and over 3 to the left. Let me try using my tool for my line so we can get this a little bit more accurately. Let's do a line. I need arrows at both ends, and I don't want it to be in white. Let's do it in black, and this way I can adjust it. We probably didn't want it to be a solid one, and let's make it, got to select it. A little Mimeo lesson here for you as well. Let's make it solid, and let's make it a little bit wider so we can see it. Alrighty. So there is where we have it graphed. Now let's go ahead and see if we can solve this equation algebraically so we can see if it truly is a true statement. So the x-axis here appears to be at, can we see that? It's going to be 1, 2, 3, 4, 5. So it's somewhere between 4 and 5 is where our line crosses our x-axis. Let's see if that's true. So I'm going to go ahead and I'm going to solve this one algebraically. So again, I'm going to get my constant terms together. Let's go back to our original. Let's put that on the screen so that you can see it. So my original sentence was 4/3 x plus 3 equals 2x. Now when I'm doing algebraically, I want to get my like terms together. So this time I'm going to kick out the 4/3 x. And that would leave just 3 on this side. And then let's look at our x's. I'm going to just change this to the side here. Remember, 2x is the same as 6/3. 6/3 minus 4/3 would give me 2/3 x. Now, I don't want a coefficient in front of my x, so instead of this being divided by 3, I'm going to multiply both sides by 3. That will get rid of my denominator. So I end up with, oh, sorry, little calibration problem again. That would give me 2x, and this would give me 9. I don't want to know 2 x's. I'm going to divide both sides by 2. So that would give me x equals, sorry, I kind of skimped here because of the calibration, 9/2. Well, 9/2 is the same as 4 1/2. And you can see that right here, it appears that our x value is 4 1/2. So, in fact, that is a true graph because when we graph the linear equation, then we substitute it in and we end up getting that the x-intercept should be at 9/2 or 4 1/2. Okay, you might need to go back and review this. This was a lot in one lesson, and we will do some more practice of that in class.